So students, let's discuss about differentiation of a mathematical function. As we have discussed that a function we can represent it by y equals to f of x. If we know the value of y depends on the value of x. If we change the value of x, obviously correspondingly the value of y is going to change. Now when we talk about differentiation, this differentiation is directly related with a differential change. Differential change is a very small change. Like say for an example, if we slightly change the value of x, y is also going to change slightly. These slight changes we call differential change, or sometimes we call it elemental change. These differential changes are denoted by adding a prefix d before the symbol, like elemental change in x is denoted by dx. Similarly, elemental change in y is denoted by dy. This d is a prefix we add before the symbol to denote that whatever we are going to represent as a very small or elemental change. Now, if we just correlate differential changes in this given function, it may be of any type, algebraic function, trigonometric function, or any other kind of function. So let if x changes by dx and corresponding change in y is dy. This implies we can write y plus dy is equals to f of x plus dx. If we replace this x by x plus dx, the value of y we are going to get is y plus dy. Well, on a change in value of x by dx, the corresponding change in y we are getting is dy. Now in this situation, the ratio of these two changes, differential change in dependent variable to the differential change in free variable or independent variable, this dy by dx we term it differentiation of y with respect to x. This dy by dx is the term which we call differentiation of y with respect to x. This dy by dx sometime written as y prime, or it is also sometime written as f prime x. If you are going to differentiate a function y equals to f of x, its differentiation is also sometimes called as derivative. This derivative of y, this is denoted by y prime, or derivative of y can also be written as differentiation of y with respect to us. Mathematically, this means that the ratio of change in y to corresponding change in x, or if we change the value of x by some value, correspondingly y changes by dy, then the ratio we term as differentiation of y with respect to x. Let's discuss some example to understand the differentiation of a function. Like say you are given with y is equals to 5x plus 3 and we are required to find dy by dx, which is differentiation of y with respect to the variable x. So what we do in this particular question is we just change the value of x as slightly, say by dx, and we assume correspondingly the value of y changes by dy. So here we write y plus dy is equals to 5 times x plus dx plus 3. Now if we open it, we'll get y plus dy is equals to 5x plus 5 dx plus 3. Here we can see that the value of y is 5x plus 3. Here this y gets cancelled out with this 5x and 3. So we can see dy is 5 dx and here dy by dx is equals to 5. This is the answer to our question. So we can simply say if y is equals to 5x plus 3, then differentiation of y with respect to x is 5. Similarly, we can handle one more example that will explain the concept much better. Like if we take up a higher order polynomial rather than a linear one, if y is given as 4x square plus 3x plus 7, then we are required to find dy by dx, that is differentiation of y with respect to x. Here again we'll follow the same procedure. We change the value of x slightly, that is by dx, and we consider corresponding change in y as dy. So here if y plus dy is equals to is 4x plus dx whole square plus thrice of x plus dx plus 7. Now we open the expression, you can see what we are going to get. Y plus dy is equals to, it is 4x square plus 4 dx square plus, this will be 8x dx plus 3x plus 3 dx plus 7. Now if you carefully have a look on the original equation, what we are having, y is 4x square plus 3x plus 7. Here we can cancel this y with 4x square plus 3x plus 7. Now you can see dy is given as 4 dx square. As we already discussed that dx is a very small quantity, and we all know very well that the square of or higher orders of very small quantity is almost negligible. So we can also ignore this factor. Remaining factors are 8x dx plus 3 dx. From here we'll get dy by dx is equals to, it is 8x plus 3, which is our answer. Or you can say y is 4x square plus 3x plus 7. Then differentiation of y or derivative of y with respect to the variable x can be given as 8x plus 3. This is the way how we analyze mathematical differentiation.